Last time, the last topic that we looked at on Java was final instance variables. We said that if you declare an instance variable like this one, final, its value only can be changed in the constructor and nowhere else. And usually, as in C++, we write these kind of instance data members, instance fields in capital letters so that people understand they are not changeable. But we don't call them const, we call them final. And we are going to look at this keyword final later in a few more cases. We looked at this, and then I think I skipped this one. Creating packages. As I said before, Java contains many packages, and we have seen example classes from a few packages, like the Java utility package or the Java system package. Okay, the packages are like C++, C libraries, plus the include files, plus the namespaces. So I mean, there is no corresponding single structure in C++ that's the same as package of Java. So basically, it contains lots of a package contains related classes in it, and whoever makes this package gives a name. For example, this might be a name. Usually, package name should consist of your internet domain name in reverse order, followed by other names of the package. For example, this could be a package for this class's homework, something like that. tr.edu.gtu.csc.csc241. That way, if you name your packages this way, it will not get mixed up with anybody else's package, because other than our GTU, there is no gtu.edu.tr, right? Other than our department CSE, there is no CSE department, and etc. So remember you should choose your namespace names in a unique way, and this is the custom of how you choose your package names. Okay, so when you define a package, when you are saying that you are making a package, this is what you should do. You are saying that whatever I am giving you in this file will belong to this package. Okay, that's the package name. Remember, java.util is a package name, and this is a package name. Okay, it's up to you. So when you compile this time class, as you see in time class, we don't have any main methods, right? This is not done for making an executable program. Okay, this is only done for creating a package. Later, if you like to use this package, you will say import con.detail. Java how to program 6, etc. Okay, so as I said, this is kind of both namespace and the library creation stuff. Okay, so try it and try to put your data in a package and try to later use it in some other program. Okay, this is how you make packages. Then I think we talked a little bit about inheritance, and we stopped at this point. The idea of inheritance is the same. Okay, you try to collect the common functionality of different classes into the same class and make it a base class. But in Java, our terminology is a little bit different. This terminology is more like standard object-oriented programming terminology. Okay, maybe I should write it. Somewhere. Okay, delete this one. So C++ terminology and Java terminology. In C++, we call it the base class. In Java, it is superclass. Okay. In C++, we call it derived class. Okay. In Java, it is called subclass. It's like the sets, right? In Turkish, kümeler, süper küme, üst küme, alt küme, right? Superclass and subclass. In C++, we call this process of deriving the derived class from a base class derivation. Okay, we derive classes from the others. In Java, we call it extension. Okay, we extend it. Okay, so we extend B from A. So B is an extension of class A. A is a superclass, this is the subclass. Okay, so some terminology difference. As I said, most of the object-oriented programming languages use this terminology of Java. Okay, it is kind of standard object-oriented programming terminology. Okay, so that's the idea. Software reusability, code reuse is the main purpose here. And most of the time, for the sake of reusability, our superclasses remain abstract because we cannot fully implement a concrete class. We say that, well, some part of it is missing. Okay, so that's called abstract classes, and they exist in Java. And create new class from exist class. So what we extend the new class from the superclass, and we say that I like everything about my superclass, but I am going to add a few things to it. Okay, and some of the things are nice, but I am going to redefine them. Okay, I am going to override them, redefine them or override them. Okay, that's what we are doing. So subclasses are more specialized group of objects. Okay, it's like this again. Let's talk about the sets. There is an motor vehicle set. Inside the set in Turkey, I think there are maybe 10 million motor vehicles, maybe 20 million motor vehicles, right? So this set has 20 million motor vehicles, but inside it there is somewhere automobiles, right? Automobile set. It's a subset of the superset, and I think it is maybe 10 million automobiles in Turkey. Okay, so automobiles are motor vehicles, but they are specialized. Why they are specialized? Because automobile is not, for example, all the automobiles are, they have 4 wheels, right? And they cannot be more powerful than some certain numbers. And what else? I don't think that there are automobiles that can carry more than 7 people, okay, or less than 2 people, etc. So these are the specialization of the automobiles. For motor vehicle is something different. For example, there are automobiles with 16 wheels, right? And there are motor vehicles with 16 wheels. There are motor vehicles that can carry up to let's say 40 people, 50 people, and etc. There are motor vehicles that has only 2 wheels, right? So it's a more general class. So we specialize it. That's the idea. Superclass and subclass. Superclass, subclass. Okay. Every automobile is a motor vehicle, but not all the motor vehicles are automobiles, right? So is a relationship again is there. So the subclasses are more specialized. I inherit everything from my superclass. I can customize my behavior and add additional behaviors. Here is an example, commission employee. Remember commission employee class? Commission employee is an employee with a name, last name, social security number. Remember, commission employee makes money out of the sales he or she makes, okay? So the gross sales times commission rate is the money this commission employee makes. And this is the public constructor. It takes all these stuff and it sets them. Okay, there's a set gross sales, set commission rate. These are the setters and setters, getters, set and get. Then set gross sales is this. It just verifies some validity. It does the validity check first and get gross sales. Set commission rate, get commission rate, and earnings. Earning is just commission rate times gross sales. And toString is there, okay? And I am giving this toString, like, okay, give me your first name, last name, and etc. Good. So this is a typical like 100 lines of code of Java class. Okay, simple class, but it has constructor and everything, setters and getters, and it defines, overrides the toString method. And now I like to make this base plus commission employee. Okay, I like to define a class whose objects should make money by the amount of the sales they make, plus they get some money, weekly money, constant money, base earnings. Okay, so that's what I'm going to do. So typical extension, this is what we do. Base plus commission employee Java. The name of the class is base plus commission employee 3, okay? And we have this keyword extends. Remember in C++, we put this column and public. Now it is extends commission employee, right? Extends commission employee. We don't have this syntax in Java. Column and public. That is in C++. This is in Java. That's the biggest difference, actually. After that, you say that I am a commission employee. Actually, I have everything that the commission employee has, including the constructors and everything. I inherit them. Okay. On top of it, I am going to define this private field, double field, base salary. Now this is my constructor. Remember, the constructors are inherited, but they are not our constructors. So we have to implement our own constructors. This one will take first name, last name, social security number, sales and rate, like the superclass constructor do. Okay, and on top of it, I am going to get the salary. So the first 1, 2, 3, 4, 5 thing, okay, will be fed to the superclass, okay, and then I set my salary in the extended class. Okay, so super is a keyword in Java. Using the super keyword, we can call the superclasses constructor. This super keyword should be the first executable line in your constructor of Java. Okay. If you use then the second line or third line as the executable line, of course, it doesn't work. It gives you a compiler error. Okay. So this is how you call your base classes constructor. Okay. Then you set the base salary, and super is very much like this, right? This refers to this object. Super refers to the super class. Okay. So using the super keyword, you can call the base classes methods, and we are going to see a few examples. Okay, so set base salary is this. Okay, because I am defining a salary thing now. Set base salary, get base salary, and then let me do this. Okay. So this is the earnings. Earnings is different a little bit. So my earning is is this the bus? You're late because. So the earning is defined as commission rate and gross sales, which is exactly the same as the superclass's earnings, plus the base salary, okay? Instead of doing this, this would have been a better implementation. Call superclass's earnings function method and call the base salary method of this class and add them up. Okay, so that's the proper way of implementing earnings. So I don't know, you will say, I don't care how the base class's earnings is calculated. All I know is I am going to add base salary to the superclass's earnings. Okay, so this is a better implementation, because if somebody later changes the implementation of the superclass earnings, then I will get affected from it. Either a bug fix or performance enhancement, etc. Good. And the toString method is very similar to the base class's toString. Base class prints all the first name, last name, social security number, gross sales, and the commission rate. On top of it, I am putting this base salary, but you might say that this is code repetition. Why don't we do it this way? Return string.format %s and %s and %.2f. So I am saying that whatever the superclass, however the superclass converts itself to a string, I am going to do the same thing. Convert the superclass to a string. Base salary will be printed like that, and this is my base salary. Okay, again, this is a better implementation of the toString method of this new class base plus commission employee. And you know how this works, right? Can anybody tell me how this works? Super is yes.
Command automatically call super string of superclass.
toString of superclass, yeah. Because in Java, all the classes should have a toString method. If you don't define it, there is one defined for you, because all the objects come from, all the classes come from the object class, and inside the object class there is a toString method. If you override it, that will be your method. If you don't, then there is a default defined one for you. Okay, so that's why it works. That's why you may use your objects in Java as a string. Okay, if somebody needs a string as a method, then you may send your object to that method, no problem. Okay, so this is the implementation of the base plus commission employee, and this is, let me get rid of this one. I think this will be useful. Okay, so let's use these two classes. Okay, let's use these two classes in a main method executable program. Base plus commission employee test3.java, and this is base plus commission employee 3 class. And I make a new base plus commission employee object. Bob Lewis, social security number, gross sales, commission, and weekly salary maybe. Okay, and I am calling its getters one by one. Remember, this first name, last name, social security number, they all belong to the superclass, not the class that I made. I inherited them. Okay, so they are all written very nicely. What else? And then I set the set base salary to 1000. Then I call the toString method of employee, and I print it out. As I said before, so this one says that printf %s, this one. The second %s, this one. But I didn't have to call this. Right? I could have said just employee. Okay? Okay, so a question for you. Remember the thing that I had erased here? Instead of writing this, if I write commission employee here, superclass, would this program compile and run? If it doesn't compile, where does it fail? Give me the line number. Well, it doesn't compile, you know that, right? Give me the line number.
Line 27 and 29.
Any other ideas? How about line 10? I am saying that commission employee object is assigned a new base plus commission employee. Is that a compiler error? This question has nothing to do with Java. This is an object-oriented programming language question. This is a C++ question. And this question is the most basic question of object-oriented programming. Who says yes? Would it work or not work? It's an error message. Who says no? Yeah, well, it should work. What is inheritance? Inheritance says that I am going to extend subclasses from superclasses, and there will be an is-a relationship between them. Isn't there an is-a relationship between commission employee and base plus commission employee? Commission employee is at the top. Base plus commission employee extends from it, right? So there is a is-a relationship. If there is an is-a relationship between base plus commission employee and commission employee, then this should be okay. This is okay. This is fine. Okay? I don't know why you are silent. That's not a good sign, but this is okay. Why? Because is a relationship and I'm using it. Okay? Every base plus commission employee is a commission employee actually, right? Every automobile is a motor vehicle. Okay? And what did we say? Every partial filled array backup is a partial filled array, right? So these are all our inheritance stuff. So this is the basic principle of inheritance of object-oriented programming. If there is a relationship, I can take advantage of it. But if employee is an commission employee, okay, the compiler, when it compiles it, it says that employee is a commission employee, okay? Let me go to the definition of commission employee, okay? Does it have a get first name? Yes, it has. Commission employee has it. It also has the get last name, get social security, get gross sales, get this, but commission employee doesn't have get base salary. It is defined in the base plus commission employee class. That's why this will fail and this will fail. This will be okay though. Okay, this can compile. Okay, this will compile. Good. So if I take these lines out, okay, tell me I take these two lines out, so my program compiles. Now this one will compile. Everything will compile. Tell me what would I get out of this line 31, 32, 33. Am I going to get, okay, am I going to get like this? Okay. Pablo is social security number, commission rate and get base salary, okay? Updated, yeah, this one. Where is the first one to be printed? Okay, system print line. Oh, okay. These are the other things. Yeah, okay. Okay, this is what I did, just to rephrase it. I made this change. This is not base plus commission employee anymore. It is commission employee. Okay, I did this and I did that. Okay, I removed those two. Now it compiles, just to keep things simple. I do this too. The output of this program, would it be like this? Of course, this one will go away because I erased it. How about the rest? Would I get the same thing or it would be different? Well, this will be okay, this will be okay, okay, gross sales, and this will be okay. Maybe I am asking this one. Would I get, okay, would I get this one or what? Again, this question has nothing to do with Java. It's an object-oriented programming question. Would it be the same or it would be a different output? If there is a summer school for this course, I am not teaching it. Okay, I don't know why I said it now, but I am not going to spend that much time. I don't have that much time during the summer. Oh, that's because most of you are going to fail from this course. That's why I'm saying. This is the most basic question. Again, I mean, I asked you about is a relationship. Nobody answers me. I am asking the second most basic question, and nobody's answering me either. Is that your hand is raising?
Yeah.
Okay. This much? Okay.
Without base salary.
What?
Without base salary.
Say it again.
Same as
Same as before?
top.
Oh, you mean this?
Without base salary.
Without the base salary, it will be printed. Why?
Because of in the top, we can get without base salary and.
But what you are saying is correct. Yes. If you assume that something what you are saying is correct, but your assumption might be wrong. What did you assume to say that? You assume that
toString is super class toString.
So you assume that toString is, toString comes from even the way base class, super class object, but I redefined them in the commission employee class, and I redefined again in the base class commission employee. You are saying that this toString belongs to the commission employees, that class, right? Yeah.
Is it gonna give garbage value?
No. What he is saying is, but not true, but his logic is correct. He say that employee is a commission employee, right? And so I am calling the toString of commission employee, but you are assuming that toString is what? You are assuming that toString is a non-virtual method, right? But toString is a virtual method. Now try again. toString is a virtual method. In Java, to your surprise, okay, all the methods are virtual. Okay? All the methods are virtual in Java. So they don't care if they are expensive or not. All the methods are virtual. There are a few exceptions, and we are going to talk about them. Okay, rest of them are virtual. So all the methods of superclass object, remember that get hash code equals toString, clone, they are all virtual, okay? They are all late binding methods. toString is the late binding method too. So if I do this, what happens? You know this? Yeah?
Right base salary.
Yeah, it will be exactly the same. Why? Because employee.toString, okay, employee.toString will call the correct version. Why? Because it will check the type of the employee object pointed by this reference employee. It's a base plus commission employee object, and it will call its toString. Okay? Yeah.
But you said one of without base salary in the top of it.
Yeah, show me this one.
Yeah.
But because I have erased it, this one, okay, get base salary, it prints it and said, I erased these two, so I cannot, yeah, okay. Without that, I couldn't compile this program, right? That's what you said. Okay, I am going to ask you the same question again, the same question. And this is my question now. What did we say? In Java, everything comes from object. So what happens if I do this? Instead of base plus commission employee, I am saying object. I am making an employee, okay, but its type is object. The first question is this. Is this line 9 and 10? Is this compilable?
Yes.
Okay, because yes is the correct answer, but why? Because there is a relationship between base plus commission employee. That's right. Okay, so it will compile. How about line 17? Would it compile? Of course not. Why? Because employee, which is an object, doesn't have get first name. So I took it out. This will not compile. This will not compile. This will not compile, right? I erase them, all of them. This will not compile. And this will not compile. How about this line 31, 32, 33? Would it compile?
Yeah.
Yes. Would it print exactly the same thing? Yes, answer is yes, because employee is an object, but if you follow the link, you are going to see that it's a base plus commission employee object. Right? So it will work that way. Okay, so again, I mean, we are not discussing much Java here. We are discussing object-oriented programming principles. And you failed very badly, by the way. You failed very badly. My object references can show both base plus commission employees or commission employees or anything you like, as long as they are a class type thing. I cannot do this, unfortunately. I cannot do this, unfortunately. Object O new int. I can't do that. Why? Because new doesn't work with the fundamental types, right? This is a fundamental type, it's not a class. Java makes this distinction, okay? But if you like to hold it to show integers, then maybe you can use this one, okay? New integer. Now it works, okay? Good, let me move on then. Okay, so our modifiers, public, protected, private, they all have the same meaning, okay? If something is public, within the class I can access it, within the subclass I can access it, in the world I can access it. What is this package? Package is the package visibility, okay? So if something has the package visibility, it doesn't have, okay, any modifiers. Okay, it doesn't have any modifiers. What do I mean by that? Remember when we define our class members, data member or method, okay, field or method doesn't matter. You need to put the public, private, protected keyword in front of each of them. The same is for the classes too, okay? So this is a private field, public method, okay? You can make them protected too, or you can omit it. If you omit this keyword, it becomes package visibility, okay? Package visibility method, that means what? Within the same package, remember we defined packages like that. I'm defining a package. Within the same package, I can access it, but outside the package, I can't. Okay? So it's kind of unnamed namespaces of C++. Remember with the unnamed namespace, in the same compilation unit, it is available. Outside of the compilation unit, they are not available, right? Unnamed namespaces. This is kind of like that too. So if you don't see a access modifier keyword in front of your class name or the class member, then that means that there's package visibility. Okay, that thing is only visible in that package. Okay, well, if I'm defining the class, I am already in the package, so maybe you could say that this type of visibility is between, okay, protected and maybe it is between protected and public, or well, similar to protect. Remember, the protected talks about the class inheritance, class hierarchy, and this one definitely less stricter than private. Private is something, okay, private, if something is marked private, okay, if something is marked private, only within the same class you can access it. Okay, only within the same class you can access it. If it is private, in the same package you cannot access it. In the subclasses you cannot access it. In the world you can't. Okay, with the no modifier, now I am saying that in the same class and in the same package it is accessible. Otherwise it is not accessible. If it is protected, then we do this. If it is public, then we do this. Okay, so that's the meaning of it. Let's go back to this thing again. In this file, okay, commission employee2.java file, there should be one class public whose name should be commission employee2. But you may have other classes, but those other classes cannot be public. Okay, they should be package level accessible with no modifiers. Okay, so it is like class helper. This class can use them. Other than this class, nobody can use it. Okay? Yes?
In Eclipse, the program, it always starts with a package. It takes all the classes in a package.
But you mean when you define the packages?
Yeah.
When you define a new package, yeah, your first executable statement should be this. Package something something.
It says package.
I cannot hear what you are saying. Say it louder. What happened to the people next to you, yesterday's people? Are they there? They are sleeping? There is nobody there? No? Okay.
It says package, and you name it, and they open brackets, and all the class is in the brackets.
I don't know if that works. I'm not sure. I don't think that it works. I don't think so.
It starts like that.
It's not like that. I don't think. The rule for this defining packages is that the first executable statement in a file should be this package. So that's the rule. If that's the rule, then you cannot define two packages in the same file using the curly braces.
It's not defining, it's creating a package from default.
Oh, you mean the import thing? You are importing?
Every time I start a new program, I have to create a package, and
Why?
the program has to be in a package. It's something Eclipse does.
Where did you get that? Why do you have to create a new package every time you write a package?
No, because it does linking that way. So if I have to write another program.
No, that's not. Well, I mean, this is the first time we have created a package, and I showed you some Java programs that doesn't create a package. Of course, you don't. I mean, package is like creating a library, and you don't have to create libraries to write programs. Maybe I don't understand what you are saying, but ask me during the break. Okay, so this inheritance thing is there. Yeah, okay, we talked about it, and we talked about this table. Where is my table? Table is nice table, yeah. Okay, memorize it. Okay, easy to memorize. And other than this, okay, it is exactly the same as C++. Well, C++ on top of this one, different from this one, we have the namespaces and unnamed namespaces. If I put this unnamed namespace thing, like the not package but unnamed namespace, okay, so unnamed namespace is visible from the class. It is not visible in the subclasses or the world as long as my subclass and the world not in the unnamed namespace. Okay, so this is our object class. Our object class, as we have talked before, everything has to be, okay, everything has to come from object class. Object class is the superclass, really. It is you cannot get any more superclasses than the object class. Everything has to come from the object class. That's why when you look at a class definition, okay, this is my favorite C++ class, and this is my favorite Java class, okay. If you look at this class, when I ask you what kind of data members and methods does this class have, you will say, well, I need to look at the documentation of the object class, and that's the rule, okay. So clone equals finalize, etc. Let's look at them one by one, okay. Clone is a protected method. Interesting, protected, yeah. So if I have a, let's say, if I have a money object, new money, $10.20, and if I have, say, money m2 m.clone, this is how you make a copy of a, by the way, there is no copy constructor in Java, but we have the clone method. This will not compile by default. Why? Because clone is protected. If you want this clone to work, then you need to override it. I am not saying redefine it. I am saying override it. Why?
Because they are virtual.
Because they are virtual. Okay. Because they are virtual. I need to override it. Okay. I need to override it. Most of the time, when you redefine a method of a superclass in Java, you are overriding it because, as I said, almost everything is virtual late bound. Okay, so clone is protected. You need to override it, make it public, and if shallow copy is what you want, the default behavior is fine. If shallow copy doesn't work, then you need to override it in a way that it makes a deep copy. For the money, maybe shallow copy is okay because remember, money has only 2 integers in it, right? Cents and dollars. Shallow copying it is fine. It doesn't have any pointers and references. Okay, so there is another detail there, clonable, and we will talk about it. If you don't make it clonable, I'm going to show you a few slides how to make how to clone an object, or how to override this clone method. Okay, it is a little bit detailed. It is more complicated than writing a copy constructor. That's why they don't talk much about how to clone objects in Java much. They kind of put it to later at the end of the semester kind of plan. Equals, as the name implies, if you call this object.equals object2, it works, okay? It returns true or false, that's it, okay? And it has a default behavior. The default behavior of equals is checking the references. If the references are the same, then they are the equal objects, right? If references are the same, they are the same object as the default behavior, and that's not good most of the time. That's not good most of the time, right? For example, if you do this, let's say I have overridden clone method, okay, m and m2. When you say m dot equals m2, Okay, when you say this will return what? Without overriding equals, this will return false. Why? Because even though I cloned it, even though I copied it from the other one, they don't share the same memory. They are at different positions. So this is, most of the time, this is not a good behavior. Okay, so the default behavior of equals is m equal m2. It just compares the references, pointers. Okay, so most of the time you need to override this, but there are certain rules like this one. If this one returns true, this one should return true too. Object 1 that equals object 2 returns true, then this one should return true too. And reflexibility, object 1 equals object 2 equals object 3, then object 1, object 3, you know that, right? This should be, and also hash code, okay? If two things are equal, their hash code should be the same. And why is this important? You're going to understand this when you learn about the hashing. And when you learn about, well, basically hash code is, by default, hash code returns the memory position in your virtual Java virtual machine, okay? So if two things are equal, then that means that they are in the same position. If I have overridden equals to look at the content of it, then their hash code should be the same, okay? So that's the other thing. Finalize, we talked about it. You don't call finalize because it is protected, okay? Even if it is not protected, you should not call finalize. Finalize is only called by what? By garbage collector. And you most of the time don't know when the garbage collector is going to work. Get class is a special function with special method. It returns, okay, an object of a class. There is a class named class in Java. It is defined in java.lang, okay. On that class, you can ask questions like, what is your name of the class, and etc. Remember the type ID thing in the C++? It is very similar to that one. And hash code is, we talk about it. These are about multi-threading, synchronization, object like locking, and etc. I mean, if you write a multi-threaded application, you are running two things at the same time, okay? You have two cores, you have two CPUs, and you are running two methods at the same time, you know that. Sometimes you need to communicate between the threads. One is producing, the other one is consuming. One is doing something, the other one has to wait until the other one is done, right? So for that kind of communication stuff, we use these functions. You will say that, okay, I'm going to wait until somebody notifies me. And this one says, okay, I'm notifying you, or I am notifying everybody who is waiting for me, okay? So this is, most of the time, you will learn about this in your systems programming course. Also, you will learn about them in your operating system course. Then the toString method is already this one. Okay, so this is our object class, and we will come back to this one. And I think I will talk about clone a little bit more. Okay. If there are no questions, let's look at the third important fundamental principle of object-oriented programming, polymorphism. We talked about encapsulation already. We talked about inheritance. Let's look at the polymorphism. The meaning is the same. The way we do polymorphism is the same through late binding. Okay, late binding. And in fact, we discussed about it, but we are going to look at a few programs of it anyway. Okay, any questions? Well, if there are no questions, let's be 0940, okay? Okay, 12 minutes of break for you, okay? 40.
Soru soracağım. Şey soracağım. Bu polimorfizm pointerlarla oluyor değil mi?
Java'da Pointer diye bir şey yok. Referans var. Referansın dışında da başka bir şey yok.
O
Dolayısıyla
nasıl oldu?
Ha?
O nasıl oldu? Pointer yok ya.
Bir de polimorfizm pointerlarla olur. C++'ın kuralı Java'nın.
İşte onu nasıl olacak diye sordum da.
Hocam
Referansta oluyor işte.
baktım IDE programının kendisinin özelliğiymiş. Zorla paket başlattırıyormuş her
Kimmiş o?
seferinde. Eclipse. Her seferinde zorla paket
Yok senin
başlattırıyor.
başta seçtiğin proje öyledir.
Her başlattığım proje paketle başlatıyordu.
Projenin kesin öyledir. Sen package yapacağız diye başlatıyorsun.
Uyandırmadı o beni. Ben ona yanmıştım ama. Hasan da ondan dolayı ama. Nasıl uyandı?
Nasıl eve bakmışım. Bakarım karşıya. 11. Ben şey yapamam. Paralel seviyorum. Tamam ama. Burada bilgisayar baksa.
10 dakikada devre yaparız. 10 dakikada. Ama soru sormuş.
Ben oynamam derim.
Bekliyorum.
Sen o zaman ben çıkışta bulsam da bana yapıyorsun. Olmuyormuş. Sen anlarsın.
Önce bir gönder.
Evet.
Akşam sokacağım. Sonra
Aynen öyle. Onu doğru.
mesajı dirençler.
Ya benden oldu da. Oğlum bir bayatacağım derken 10 puan gidiyor. O 10 puan yaptığımda şey değmeyecek yani. Bugün yollaman lazım.
Hemen yazdım.
Allah yardım et. Önce ne olur ama? Ben ne yapacağım? Bir dakika bak var oğlum ya. Soru yanlış değil yani.
Çıkacağını biliyorum. Bilmiyorum o. Hesapla yerinden çıkacağını geri yazıyor. Doğrusu doğru.
Abi ya benim de var bir şey.
Bak. Şöyle bir devre yaptım. Acayip.
Aynen artık 500 liraymış.
Ne olur?
Olsun.
Ne olur baksana. Bak şimdi şunu harfi vereceğim. Bu seri. Buna bu seri. Bu Vücut bir yapar ya. Sen nasıl yaparsın onu? Yap hadi.
Durun mu?
Ne? Bak. Şu 3 seri olacak. Bunlar birbirine paralel olacak. Nasıl yapacaksın?
Şimdi yapmak.
O öylesin.
Şurası sıkıştırılmış da sonra. Şuralar böyle yapalım.
Ya format doğru mu? Sana söyleyeyim. Şimdi şuradan artı vereceğiz. Sınıf jumper'lık çıkartamayız.
Sarı. Para değil.
Nasıl var?
Değil oğlum. Son başı sonu aynı mı? O başla. Neyse.
Aynı tabi oğlum.
Değil. Başı aynı, sonu aynı mı? Aynı noktalar.
Buna bu paralel değil.
Aynı noktalar mı? Yok.
Yani paralel değil zaten oğlum.
Bu ikisi paralel mi?
Hayır.
Değil. Tamam.
Şununla şu seri.
Bununla,
Şununla şu paralel.
hayır. Bununla ikisinin toplamı beraber. Bak. Burada bir direnç var.
Tamam öyle de.
Öyle demez.
Dur. Devreyi çizeyim.
İkisinin toplamıyla iki paralel.
Tamam doğru. Onu nasıl anladın? Şu nokta, şu nokta. Şurada ikisinin toplamı da aynı yere varıyor.
Böyle bak hocam bak. Başlangıç bitiş değil mi?
Tamam.
Aynı bitiş şurası. Ama aradaki dirençler ne varsa ne yapıyor? Bunların değişik dirençleri. Bunlar toplamı. Bu başlangıç
Ona
bitiş.
da paralel. Tamam.
Hangisi? Bak bakalım. Başlangıç. Başlangıç. Aynı. Dirençlerin toplamıyla bu takviye.
Tam tersi değil mi? Bundan mı toplamı buna paralel?
Neyle neyin toplamı?
Bundan mı toplamı? Yani seri.
Yalnız öyle olmuyor diyor video.
Ama şeye buna paralel. Öyle.
Bunları toplayamazsın diye çünkü burada bir tane daha çıkış var. Burada yok zaten. Şu var. Şu kısım var.
Tamam işte bunda bunu topla.
Hayır dur. Sen bununla bunu toplayamazsın. Ya buna paralel diyemezsin.
Ya anne işte şuna paralel sonra bunları
Çünkü bak şuradan bak. Bunlar bu ikisi olmasa yapardın ya. Sadece üçü olacak.
Tamam işte.
Ama bunlar var. O yüzden yapamazsın. Niye? Buradan bakınca abi sadece bunu görüyorum. Böyle en köşedeki bağlantısız olmayanları toplarsın. Köşeden gelirsin.
Tamam şimdi çalışıyor mu? Tamam söyle.
Her şey çalışır abi.
Tamam artıyı vereceğiz.
İstediğin gibi çalışır mı? İstediğin gibi çalışır mı? Ölç abi. Ampermetreye getirmedin şeyi.
Hayır.
Ampermetreye alacaksın abi.
Aynen çok yardımcı oluyor ya valla.
Alacaksın ya. Ben para veriyorum değil mi abi? Eğitimin tanışıyor. Tatil değil. Tabii bir kartonla ile anlamıyorum.
Neyi var? Valla.
Şey ya işte 3. 4. davulun mesela şeyini bırakmadığında çizgi kağıda bakarak
Bunu alacak mı?
direkt şey
Ne yapıyorlar?
Kullanmayı biliyor musun?
Ne yapıyorlar? Sen bir tanesini mi durduruyorsun?
Herkes önceki deneyim
Öğrenci geliyor. Şu derslerde.
Hepsini mi?
Bunu nereye tutacağız? Şuraya mı?
Tümü mü yani lavın?
Hangi
Bir lavın tümü mü?
yok ya direnci.
Ha, bir de evvel falan. Çok 20 dakika. Şeyleri falan.
Tamam. Kalacağız. Aynen.
Şöyle bir mod
Tersten
veriyor. Amper'i ölçüyor. Oradan direnci hesaplıyor.
rastgele dağılıyor işte.
Ha.
Rastgele işte. Onun bir parçasını sunuyor işte.
Öyle de yapar ya.
Zaten genelde de daha hızlı değil.
Bunun aynı oldu.
Şunları anlamadım. Kaç oldu?
Aynı evre.
Kahve için turuncu.
Buradan bir eksi çıkartacağım ama o eksiği bozanlardan.
Ha, 16.
Bak şu basit.
Ama 14 civarı.
Şöyle oldu.
Neymiş? Bak.
Aynen.
Yeşil de aynı.
Ben şöyle taksak. Oğlum ben geldim yanıma ben de bir soru sordum ya. Git ya sen de düştü ben.
15. 15 mi?
14, 25, 15 arası.
Ama şuradan şimdi antiye şuraya dokunduruyor. Cam buradan mesela. Şuradan bir eksi çıkartacağım. Ekleri yapıştırırım. Çalışacak. Eksi buradan yani. Şu buranın hepsi eksi olacak. Tamam buranın hepsi eksi olacak. Bu taraflarda artı olacak. Şu çizgiyi yapmak için şöyle bir şey yaptım. Tamam. Tamam öyle oldu. Tamam. Eksi de şuradan verdim. Eksi ucu bağlayacağım işte. Tamam burası eksi oluyor yani. Sıfır.
A'ya artı koyacağız zaten. B'ye eksi.
Tamam.
Ama sen ana değil. Çok güzel.
Evet. Şu yapmak, şuraya çizgi yapmak daha iyi şey oldu demiştim. Sonra hepsine şuraya bir para verdim. Tamam bakalım. Şununla şu seri. Şuna para verdim. Şuna hepsini al. Bunların şeyi bırak. Seri. Aynı şey oldu. Gösterden bana şu an. Yoksa kalacağız. Kaçta şey?
Okay, polymorphism is, the meaning is the same. Many faces. When you call a method through a superclass reference, the correct subclass version of the method is called based on the type. So this is exactly the same thing, but in C++ we talked much about late binding and early binding. In Java they don't talk about much, but because as I said, all the public methods that you define, they are all virtual methods, virtual functions. In fact, I mean you will not see this keyword virtual in Java. As I said before, everything is by default virtual. There are exceptions, of course, and you make things non-virtual by defining in a certain way. So if you don't define them as anything, okay, all the methods are virtual. That's why they don't have the virtual keyword. Okay, so something like this. If I have okay, this is nice, right? If I have an array of objects, and I get it, and I'm using an enhanced for loop, I iterate over this array of objects, and I call this toString on each of them, right? It works. Okay, it works. Why? Because each object should have a toString method because it's an object, but it so works because toString is a virtual method, okay? It is late bound. So every time I make this call, print line o.toString, the meaning of toString changes depending on the object type that I am sending to this PR method. Okay? So this is very nice. This means that I can have an array of anything, right? Array of anything. Of course, not including integers, doubles, and bytes and booleans because they are not reference types. What else? Okay. So I can make this real, right? I have a money object. I have a string object. I have an object array, new object 2, and M1 is assigned, S1 is assigned, and I can call this PR and it will work. It will properly print money and string by this method. This is possible because the meaning of this toString is determined during the runtime. When I am executing this line, what does O point to? I don't know during compile time, but during the runtime, I will know it. Okay. So we already did this, actually. I already showed you examples of it. Let's continue our discussion and let's introduce other things that we know from C++, abstract classes. Well, in Java we have, of course, abstract classes. What is an abstract class in C++? If a class has at least one pure virtual function, we call that class an abstract class. Why? Because we can't have objects of abstract classes, right? That's why they are abstract. We don't call them concrete, they are abstract. Okay. In Java, the idea is the same, but we define abstract classes as abstract. Okay. We put this keyword abstract at the beginning of the class definition. Public abstract class something. Okay. Abstract class something, that's the keyword. We make them abstract. Also the methods too. There are no virtual methods in Java, but there are, as I said, we don't call them virtual, okay? They are late bound most of the time. But if you like to make a pure virtual method in Java, you make it abstract. You put this keyword abstract in front of the method itself. Okay, let's look at this hierarchy. This is our popular hierarchy. I think we looked at this in the C++ examples. Now I'm looking at in the Java examples. There is an employee class, salaried employee, commission employee. See this hierarchy? We already did this. An hourly employee. Okay, we are going to make this, but the employee class is going to be an abstract class because I don't know how the earnings method would work for employee. Okay, so employee method, employees earnings method will be an abstract method, and employee will be an abstract class. Okay, let's see it. Okay, this is a nice table. Okay, two string methods. Well, I'm just looking at two things: earnings method and two string methods of each class. 1, 2, 3, 4, 5 classes. Employee is an abstract class because I don't know how to implement this earnings. Okay. ToString method of employee works this way. It will print the first name, last name, and social security number. Salaried employee, ToString works the same way, but on top of it, I am going to put these. Hourly employee is exactly that, but I am going to put these and etc. And this is how their earnings are calculated. Salaried employees' earnings is calculated using weekly salary. Commission employees' earnings are calculated using commission rate times gross sales. The rest is you already know. Okay, let's look at the code. Public abstract class employee. Okay, this is how you make a class abstract in Java. Keyword abstract. In C++, we don't have keyword abstract. Okay. In Java, we have keyword abstract. If you like to make a class abstract, you declare it as an abstract. In Java, we don't have keyword virtual. Okay. But we know that everything is by default virtual. So these are my private fields: first name, last name, social security number. For every employee, I have to have this. Okay, this is my constructor for the employee, and this is the setter, getter. Okay, and this is the setter for the social security, get social security, toString. Okay, toString. toString says that get first name, get last name, and etc. So nice interface, yeah. It doesn't use the fields directly. It uses the public interface. Nice. Earnings, I don't know how to implement it. Public abstract double earnings. In C++, we would have written it like virtual double earnings equal to 0, right? That's the pure virtual function. This is an abstract method. No implementation here, and that's it. Okay? That's it. That's the end of the class definition. By the way, in Java, you have to define all of your methods in just single go, right? You start your definition at line 5, okay? And I ended it here. You cannot divide your class definition into two. One is defined in this file, the rest is defined in this file. Because as I said, we don't have headers in Java, right? In C++, we separate the header from the implementation. So our implementation could be separated out to many files. But in Java, it has to be done in the same file within the braces. Okay, good. So, earnings, that's it. And salary the employee, remember this, what we're going to do, hierarchy, is an employee. On top of the employee, I'm adding this. My constructor, calling the superclasses constructor, set weekly salary, get weekly salary, and our earnings is here. Get weekly salary is our earnings. Earnings is not an abstract method anymore. I defined it, and my toString method is like this: salary the employee, percent as percent. Okay, so this one. Okay, let me do it this. Okay, this one used to call it calls super.toString, but I don't have to call toString. It is called automatically if I just say super. Okay, so it prints it. Very simple class, 40 lines of code, but I know that it includes all the functionality of the superclass employee. Okay, let's continue. All employees and employee, 2 new things and lots of stuff. 3 of them will be sent to the superclasses constructors. I set them. So I am going to get, I will have setters and getters for the wage and hours. Setter for the wage, validity check. Setter for the hours, validity check, and getters. And earnings is this. Okay, if I am less than 40 hours, then this is it. If I am over 40 hours, then I do overtime. So I get 50% more for each hour that I am working. And toString is again, call the superclasses toString and do these. Okay, this is hourly employee. Commission employee is, okay, 2 more things on top of employee. Extends employee, and nothing interesting much, but an override. Well, I am not overriding earnings because there was no earnings. Okay, it's still I am implementing it, and this one is overridden. Good, and the final class is this one. Final class is the base plus commission employee, extends from commission employee. Not from employee, but commission employee. Okay, so this one is a subclass of commission employee. It is also a subclass of employee. It is also a subclass of class object. Okay, superclasses constructor is called. And again, I'm going to have setters and getters for base salary. And earnings is here, okay? So super.earnings plus get base salary is the preferred earnings implementation. Okay, that's it. So I have implemented all of the classes, including the superclass. let's write some test executable program. Payroll system test, payroll system dot Java. I make objects 1, 2, 3, 4 objects. Okay, a salaried employee object, hourly employee object, commission employee object, base plus commission employee object. Okay, they are all nice, no problem. So what am I gonna do? I can call their earnings methods and it's going to work. Okay, so I am calling their earnings one by one. And I am going to do this. This is interesting too. Okay, make an employee array. So this is an array of employee references, right? Not for employee objects, because there is no such thing as an employee object. Employee is a abstract class. You cannot make employee objects. But this is an array of employee references, and I am going to assign the salaried employee, hourly employee, commission employee, and base plus commission employee to these array elements. Okay? Now using this array elements, I can call their earnings, I can call their names, I can get their toStrings and etc. It will be polymorphically decided. Okay, so yeah, this is nice, right? Line 46. Enhance for loop current employee, and I am calling this toString method of current employee, and I'm printing it out. Very generic code, right? When I'm compiling line 46, I don't know which toString will be called. Okay, during the runtime, it will be determined using the late binding mechanism of Java. It's a pointer, it's a reference. It will find the object. It will ask the object, what are you? Okay, it will say that I am this. Okay, where is your virtual function table? I am here. Okay, so inside the virtual function table, it's going to find the toString method. It's going to call it, and in whatever it returns, it will be sent to the print line. Okay, so that's the print line thing. And let's look at this one. Interesting new stuff here. If current employee is an instance of base plus commission employee, I am trying to do some, okay, in this case, downcasting, right? Upcasting is always okay. Remember, this direction is upcasting. All the base plus commission employee objects are employee objects. There is a relationship. But in this case, I am trying to see if there's current employee an instance of base plus commission employee. How did we do this in C++? We do a dynamic casting to the base plus commission employee. If dynamic casting works, if it doesn't return a null pointer, then I say that, okay, I am successful. I can use this object as a base plus commission employee object. In Java, you do this. You ask this question. Is this an instance of this class? And the compiler generates code that makes this test. I can know that, okay. If it is true, then it returns true. Then when it is true, then I can say that, okay, then I am typecasting this employee to base plus commission employee. So you can do this. If you know that this is true, you can do this in Java, if you know it. If you're not sure, then this is going to throw if that's not the case. Okay, so in order to prevent any throws, I am going to do this. I typecast it, and then since I know that this employee is a base plus commission employee, I get this base class, base salary. I make a raise. I added 10% to the base salary and set it and print it, and that's it. So this part of the code will work only for base plus commission employee objects. Not all the employee objects, but base plus commission employee objects. Very specific code for that part. The last part, lines 63, 64, again, it is generic, right? Current employee.earnings, polymorphic call again. Okay, polymorphic call. Good. Any questions so far? Okay, so this is how we did the polymorphism. This is how we do the abstract classes, abstract methods in Java. Since I am not telling you what an abstract class is, why it is useful, what late binding is, what early binding is, it goes very fast. I am only telling you the mechanism of doing the same thing. In Java, it is very similar. What is the difference? We don't do the dynamic casting. We ask this question, instance of, it's an operator, okay? Binary operator, it takes two parameters. On the left, a class name, on the right is a class name. You ask this question, is current employee an instance of something, okay? So if I put class object, okay, if I put class object here, object, then everybody is instance and object, right? This will always return true. Well, maybe not for the integers and that kind of stuff. Okay, for all the reference types, I can ask, is an employee an instance of object? It will be always yes, true. Okay. So instance of works that way, and this is going to work that way. By the way, what was the rule for the polymorphism to in C++ to work? We said that you need to use either a reference or a pointer to the base class, right? That's what we did. If you call that virtual function directly on the object name, it's not going to work, right? Well, in Java, we don't have the object names directly, right? We don't have objects in our hand. We have their references only, okay? That's it. This is an employee reference, okay? This is a reference. There is no other way to call a method of a class, right? You have to use the references anyways. So that's why we are not careful about that in Java. It's going to work that way anyway. And all the methods are virtual by default. All the methods are virtual by default. So we don't have to be careful about that either. So the rule is, everything is virtual by default in Java. If you like something to be not virtual, then you have to specify it, just the opposite of C++. Okay? Being virtualness, okay, being a virtual is the norm in Java. It's not a special thing, it's the normal thing. If you like to be non-virtual, early bound, then you are going to do something, and I'm going to show you. Okay, and this one uses the get class. Remember, get class returns an instance of class, okay, and get name is the name of the class. So I can print the name of the class on the screen, and we did the same thing in C++ too. Okay, good. Employees, yeah. Okay, good. Yeah. So, any questions so far? Question again. I am going to ask you exactly the same question. Exactly the same question. If I make this object and object, tell me the first compilation error line number. Line 33. Would this compile? Compile, yeah, I'm getting a for object references. How about these? Would these be an error message? 36, 37, 38, 39? No, because there is a relationship, right? This one, employee, current employee, employees. Is this an compilation error? Line 44?
No.
No. I mean, no to no. Yes, it's a compilation error. Why? Because not all employees are, not all objects. This employees is an object array. It's not an employee array, right? This one says this is an employee. Not all objects are employees. right? So I need to make this an object, right? Okay. How about 46? Is this a compiler error? No. Why not? Because current employee is an object and it should have a toString method. It's not a compilation error. The nice thing is this one will work as before, right? This one will work as before. Okay, good. Let's continue. How about line 49? Is this a compilation error? What? 49, yes or no? Compilation error or no?
No.
No, it's not. Why? Because I am saying that is this object an instance of base plus commission employee? Okay, it's not a compilation error, and the nice thing is that it's going to work as before, right? It's going to work as before. So if it's a base plus commission employee, it's going to say yes, and I will do this conversion, I will do it everything right, and it will be okay, right? If it doesn't work, if it says false, it is false anyways. How about this line? Would it work? Line 64? No, right? It will not work. Because for an object, there is no earnings method. This will give me a compilation error. So that would be a bad thing. Okay, how about this one? Would it work? This one? Would this work?
Yes.
It will work as it is, right? Because get class is an object thing. And it will work as before without any changes. Okay, good. So the one nice thing about telling you about Java at the end of this course is we are repeating our discussion on polymorphism, abstract classes, and etc. And we are looking at the same concept from a different angle. That's why, even though it's kind of a very condensed discussion of Java, it helps a lot. At least it helps me. And I don't know about you, but it helps me. Okay, good. Let's move on. Okay, instance of is a operator of Java. There is no instance of operator in C++. Okay, we say that I am going to do a downcasting, but before the downcasting, okay, the downcasting is just the opposite of is a relationship, right? I am not sure if it's going to work. Before I do the downcasting, I ask this question: is this an instance of this? If the answer is yes, then I do the downcasting and continue that way. Okay, so instance of is one thing. Again, get class is inherited from object. It returns an object of class, an unfortunate name, and get name is a method of class. Okay. Are there any questions so far? Final methods and classes. Remember, final keyword, we use it to make some instance variables constant. Okay. Now I'm going to use the same final method, final keyword on the methods. If you make a method final, it cannot be overridden in a subclass. You cannot override it. Okay. So private and static methods are implicitly final. Because if a method is final, if a method is private, you don't have access to it from the extended classes, right? From the subclasses. So it cannot be overridden. It is by default final. Statics are the same thing too. They are implicitly final. And all the final methods are resolved at compile time. What does that mean? All the final methods are early bound. They are not late bound functions. They cannot be virtual. Okay. They cannot be used at polymorphism. So it's kind of final keyword in this case is kind of the opposite of the virtual keyword of C++. Okay. So you can say that my method is a public method. If I make it final, that means what? That means what? It's going to be not late bound. Its definition is decided during the compile time, but I cannot override it in the subclasses. But overriding means that, okay, overriding means that I am going to change the meaning of this virtual method, right? So if a method is final, then compilers can optimize by inlining the code, by deciding the meaning of that code during the compile time, so it is efficient. Okay, it's not flexible but efficient. That's the default preference of C++. Make all the methods like early bound, okay? Since I cannot override them. And there is this final classes. If a class is final, then you cannot extend it, okay? Cannot be extended by a subclass final classes. So the final is used in many cases in Java in this case. For the method to be a final, that means what? It is not a virtual method anymore. It's an early bound, early binding method. Okay, if a class is a final class, it cannot be extended. If an instance variable is a final instance variable, it cannot be changed. It's kind of constant. Okay, so 3 different uses of this final keyword in Java. After C++ 11, okay, we can say the same thing for C++ functions. If I declare a function final in C++, it cannot be redefined or overridden. And for a class to be final again, its meaning is the same. So they borrowed these ideas from Java, and they introduced this final keyword in C++, and we talked about it before. Okay, good. So final is that way. Okay, another important closely related concept in Java related to inheritance is the interface. Well, interfaces are not classes, but I like to think them as classes, very special classes. Okay, interface is a very special class that contains only constants and abstract methods only, okay? Only constants and abstract methods, nothing else. And everything in an interface has to be public static final. Not everything. All the fields are implicitly public static final. All the methods are implicitly public abstract. That means what? That means you may not implement anything in an interface, okay? They all have to be abstract methods. And you cannot have any modifiable variables in an interface. Everything has to be public. All the data members are static, and they are final, they are constant. Methods are public and abstract. Okay? So definitely this is one more level more abstract than abstract classes. This is more abstract than abstract classes, right? Because in abstract classes we have some definitions, we have fields, okay, modifiable fields. This one interface, we don't have those. And our classes, okay, they don't extend from an interface, they implement the interfaces. Okay? And so you are saying that what's the difference between a very abstract class and an interface? Well, Java treats them differently. Java says that interfaces are not classes. They behave like classes, abstract classes, but they are not classes. And one difference will come in a few minutes. We say that, remember in C++, we can say that in C++, a student is a class, a worker is a class. In C++, we can have multiple inheritance, right? I derive from both student and worker, okay? Public student, public worker. And there is a relationship between this one and these two. This is called multiple inheritance. But remember we said that, we say this. Let's say if they are coming from the same root. Okay? So there is an inheritance path here. There is another inheritance path there. The student worker inherits from a person in two different ways, and that creates problems for the compilers, makes the compilers very complicated. Java says that, no, I am not going to allow this. There is no multiple inheritance in Java. Java says that, no, there is no multiple inheritance. But we say that, well, I mean, multiple inheritance is a very nice thing. Why don't we use it? We like it much. Java says that instead of having multiple inheritance, we are going to have multiple interfaces. You may implement as many interfaces that you like. Okay? You can say that, okay, this is my interface 1, interface 2, interface 3, okay? This class, Java class, can implement this interface, and this interface. This implementation of interfaces are shown using this dashed lines, and this one can extend a concrete class or an abstract class. So it can extend only one class, but it can implement as many interfaces as you like. And Java uses this a lot. So I can be both interface 1, interface 2, interface 3, and this abstract class or another class. Okay? And you might think that, well, this doesn't make much sense. I mean, what are we solving here? Why are we behaving this way? This will be clear when I introduce this to you. Let's look at this one. Payable is an interface. What is the Turkish word payable? Payable. Ödenir, ödenebilen, ödenir. For me, an invoice, an employee is an payable. Faturayı da öderim, employee'ye de öderim, değil mi? Para veriyorum, cebimden çıkan para gibi. So this hierarchy is, invoice is a payable, employee is a payable, salaried employee is an employee. But payable is an interface. It will not define anything that is implementable. It will not have any data members or fields, right? But I know that invoice and employee are payable, so maybe this should define a method without implementing it, pay amount or something like that, okay? Let's build this hierarchy, okay? That's it. Public interface payable, get payment amount, that's it. Okay, this is not public class payable, it is public interface payable. What was the rule? Inside an interface, everything is, all the methods are public abstract methods, okay? So you don't say public abstract double get payment amount. This is the way they choose, okay? Say double get payment amount. So I know that this get payment amount is an abstract method. I know that it's a public. You cannot do anything other than that. It has to be public and abstract. If it's a method. If it's a field, if it's a data member, it has to be public, public, final, and what? Static, right? It has to be that way. Okay, so there is no private or protected or package level visibility in interfaces. Okay, so I defined it. Simple, payable Java, just 3-4 lines of code in it. And let's look at this. Let's look at this invoice class. Invoice class is not an abstract class, but it doesn't extend payable. It implements payable. Interfaces are implemented. Classes are extended. And you can implement as many interfaces as you like. Okay, so implements payable, and what for an invoice, For an invoice, what would you have? The part number, part description, quantity and price per item. Right? Bir faturada ne yazar? İşte parça numarası, faturanın tanımı, kaç tane var, her birinin fiyatı ne kadar, right? So I do that. Setters, constructor for the invoice. Okay. See, I am not calling the super class as constructor because super class or this interface doesn't have a constructor. Even if it has a constructor, it cannot implement it. I am not calling anybody, right? I am saying that just I am a payable. Since I am a payable, since this one defines this get payment amount, okay, and since I am not an abstract class, I need to override that method. And that method, get payment amount, is here. Get payment amount is get quantity times get price per item. Okay? Good. So the rest of them is kind of as expected, setters and getters and that kind of stuff. So this is our invoice class. It's a concrete class, not abstract class. It is instantiatable. It's easily usable. Let's look at the other side of the hierarchy, employee. Employee is a payable too, okay? Payable too. It implements payable. These are the stuff. Our constructor and usual employee. But I know that since I am a payable, I implement payable, I need to define get payment amount. And here it is. Get payment amount. What? There is no get payment amount? Well, it says that I don't know how to calculate the payment amount for an employee because employee is a very generic thing, okay? So I defined everything. I did everything that I can about the employee, but I cannot calculate it because I don't know the details of that employee. Is it an hourly employee, commission employee, and etc. That's why employee stayed as an abstract class, right? Employee stayed as an abstract class because I don't know how to define this get payment amount. Okay, so well, if it is that way, then it's going to be that way. But remember our hierarchy. Our hierarchy is like this. There is one more one. Okay, salaried employee. Okay, let's implement the salaried employee. Salaried employee says that I am extending employee, not implementing. Okay, I am extending employee, and employee implements payable. So salaried employee is a payable too. So everything. This time I call the superclasses constructor, and our toString calls the superclasses toString, and our get payment amount is defined get weekly salary. Okay, so get payment amount. Very quickly, let me show you a payable interface test. See, I am making 4 payable references. What is payable? Payable is not a class, it's an interface. Okay, interface is even more abstract than an abstract class, right? I am not making 4 payable objects. I am making 4 payable references. 4 payable references. 1, 2, 3, 4. And I put these invoices, 2 invoices and 2 salaried employees in it. Is a relationship holds between invoice and payable, between salaried employee and payable, right? And then I do this, right? I iterate over payable objects one by one. I know that toString will work on all the payable objects because of the is a relationship between payable and the object class. And I know that each of them should have a get payment amount. Okay? So, well, I think, question for you. If I change the implementation of this payable to public abstract class payable and abstract double public abstract abstract double get payment amount. If I did this, would this whole code compile? The answer is yes. Yes. Because I'm making an abstract class payable. Of course, instead of implementing the payable, I extend the payables, etc. The whole system would compile and run. So what is the advantage of using this interface then? I could have done the same thing using the abstract classes. Why do I bother with having an interface here? If abstract classes are good enough for this example. Yes? For multiple interface implementation. Well, in this case, I didn't take advantage of it, but in the other cases, I would. And in fact, I am going to show you something. For example, Java documentation. It's going to tell me, okay, yeah, go to Java. Okay, Java documentation, just a simple class, for example, string. Let's go to the Java documentation string. And string is a class that comes from Java object, okay? It extends from object directly, but it implements serializable character sequence and comparable interfaces. Most of the time our classes are like this, okay? They will all have to come from object, but they will implement a number of interfaces. For example, if I go to, where is my all classes? Go to any class, go to, for example, window, how many? J window, okay, good. Or, okay, window event. Just a random class that I know that well, unfortunately, this one didn't come. It just implements a serializable interface. It comes from a hierarchy. This hierarchy is just a single line hierarchy because there's no multiple inheritance in Java. It implements this one. How about this one? Let's go to this one. Again, this one only implements that guy. How about this one? Event object. Well, most of the time, I don't get it, sorry. I am trying to get a class where it implements many things. I know okay, class, all classes. Let's go to a hash set, linked hash set. Okay, so it implements serializable, clonable, iterable, collection, and set. Okay, say that I am going to behave like one of them. If inside the clonable is an interface. Okay, clonable is an interface where it defines this clone method. If you are clonable, then you need to implement this clone method. Okay, if you are iterable, then you need to implement this iterator method. If you are an iterable, so by giving this class says that I am going to implement clone, I am going to implement iterator, I am going to implement such and such from all of these, right? So I can behave like a set, I can behave like a collection, I can behave like an iterable, right? So Java uses the idea of multiple inheritance very widely, very liberally, right? But it doesn't use the real multiple inheritance, but it uses multiple implementation feature of these interfaces. Okay. I guess that's it. People are outside, right? They are coming in. Any questions? We will continue on Monday then. As I said before, I think I missed a few classes, even though I don't miss any of them. So I will do 1 or 2 lectures after the classes and during the makeup week. I think on, okay. So next week we will have 3 lectures, 1, 2, 3. On 2nd and 3rd, I will do 2 more lectures, January 2nd and January 3rd, okay?